myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the today's lecture, we are going to learn about problems based upon magnetic field intensity and the magnetic flux density in electromagnetic waves and transmission lines. So before going to solve some of the problems based upon this magnetic field intensity and magnetic flux density, let me first tell you about the notations which we are used for the magnetic field intensity and the magnetic flux density. So for the magnetic field intensity is denoted with H and it is measured in magnetic field intensity is denoted with H. Generally it is represented as a vector form, and magnetic flux density is denoted with B. Here this B is also a vector. Why? Because there is a relation between this magnetic field intensity H and the magnetic flux density B is given by here B bar equal to mu into H bar. Right? So where flux density can be measured in Weber per meter square, or sometimes it is used to measure in Teslas. So H or B. So B, the relation between magnetic flux density B and the magnetic field intensity H is given by B bar equal to mu into H bar, where this mu is said to be permeability of free space for permeability of the material, and it is given by mu naught into mu r. For a free space medium, this mu r can be considered as 1, then mu is replaced by mu naught. And its value is given by here 4 pi into 10 power minus 7 Henry per meter. And this magnetic field intensity is used to measure in ampere per meter. Right? So keep in mind this magnetic field intensity notation as H, and magnetic field intensity flux density as B, and the relation between B and H as B equal to mu into H. And for a free space medium, this permeability value is given by 4 pi into 10 power minus 7 Henry per meter. So we use all such notations in order to solve the problems based upon magnetic field intensity and magnetic flux density. Right? So here, given the magnetic vector potential, so magnetic vector potential we used to consider the magnetic fields as A, which is equal to minus rho square by 4 into Az, and it is to be measured as Weber per meter. Then from this, calculate the total magnetic flux crossing the surface, that is phi equal to pi by 2, 1 less than or equal to rho less than 2 meters, and 0 less than z less than 5 meters. Right? So here if you observe, the notations are rho, phi, z variables are given. So rho, phi, z are the notations for cylindrical coordinate system. 3 variables of the cylindrical coordinate system means rho, phi, z are denoted. Now, differential components of 3 cylindrical coordinate system variables are given by here d rho and dz. If you want to measure the phi component, we need to consider length of an archetype. Why? Because cylindrical shape. If you want to find the length of an arc, we can use the formula as L is equal to r theta. So this phi component can be written as rho into d phi, where r is the radius and rho be the radius of a cylinder shape, and d phi. So differential components of cylindrical coordinate system means d rho, rho d phi, and dz. Right? So now phi equal to pi by 2. So if a fixed value or phi equal to 0 plane resembles rho z plane. So differential variables are we need to consider rho and z. Right? So depending upon this plane, we are going to write the surface ds formulas. So first we need to find, given A is given as A is equal to minus rho square by 4 into Az is given. Now using this A, we can calculate the total magnetic flux. Means the magnetic flux is represented with phi, and this is given by integral S B dot ds. Right? Where B be the magnetic flux density and ds is to be obtained from the given plane. So in order to find this B, first use A value. And there is a relation between this B and A is given by here B equal to del cross A, right? So if you want to express, means given A is expressed in terms of cylindrical coordinate system, hence B can be written as B equal to del cross A. So 1 by rho, why? Because we are talking on cylindrical coordinate system, hence that is to be represented as here 1 by rho. First we need to write unit vectors as A rho A phi and AZ, and the second row, we are supposed to consider partial derivative terms, that is dou by rho, dou by dou phi, and dou by dou z. And in the third row, we are going to consider the magnitude terms of the given A. So A equal to here AZ, unit vector direction in the form of Z only given, and the rest of the two will be zeros. Hence, A row component and A phi component 0, only AZ is given, that is minus rho square by 4, right? So upon expanding this equation means, which is equal to, how are you going to write? Which is equal to 1 by rho into, first A row, if you consider A row, then A row into dou by dou phi of this minus rho square by 4. We are differentiating this one with respect to phi, and the variables inside that is rho, hence this will be considered as constant. Then dou by dou phi of this minus rho square by 4 is becomes 0. 0 minus dou by dou z of 0, this will be 0. Then minus rho into A phi into, and A row into means this in the second row, if you consider, then dou by dou rho of minus rho square by 4 is the first one, and the next one will be 0. Then plus AZ into, so A row AZ into means these two becomes 0, cross multiplication between 2. If you find the determinant, then this will be equal to 0. So from this, B equal to, how you are going to write? 1 by rho into, first A row into this 2 becomes 0, AZ into this becomes 0, then minus rho into A phi into dou by dou rho of minus rho square by 4. So minus rho square means minus 2 rho by 4. If you differentiate this one with respect to rho square, then it will be 2 rho, and minus already in the formula itself it is there. Then 2 gets cancelled, which is equal to 1 by rho into this minus and this minus. If you multiply, this becomes plus, then rho into rho becomes rho square by 2 into A phi. And this gets cancelled. Rho by 2 into A phi is the value is to be obtained for the this B. Right? So B is to be measured in Weber per meter square, or sometimes Tesla. So from the given A minus rho square by 4 into AZ, we will evaluate the expression for magnetic flux density, and it will be B equal to rho by 2 into A phi Weber per meter square, or Tesla can be obtained. Now from this, we are going to evaluate the flux which is crossing through that surface. Hence the formula is psi is equal to integral S B dot ds. So here rho z plane means integral S means we are supposed to integrate, means integration is considered with respect to the two components. So that will be given by here. Rho is ranging from 1 to 2 and z is ranging from 0 to 5. So rho equal to 1 to 5 and z is equal to 0 to 0 equal to 1 to 2, z equal to 1 to 2, z equal to 0 to 5. And B value rho by 2 into A phi is to be obtained from the previous analysis, the relation between B and A. If you find the B equal to del cross A, if you solve, then B value is to be obtained as rho by 2 into A phi, and ds means, in order to write the formula 1 to 2, 0 to 5, that will be 1 to 2, z equal to 0 to 5, B value is rho by 2 into A phi into ds value. So now to write the ds formula in cylindrical coordinate system, the differential components are d rho d phi, and dz. So if you observe in this B, the formula B value is to be obtained in phi direction. So phi direction means we are supposed to consider the plane z and rho components. Hence, ds formula becomes d rho dz into a phi. Right? So in place of this ds, if you substitute d rho dz into a phi, then a phi dot a phi means dot product representation of two same unit vectors. Result is 1. Then if you multiply a phi dot a phi, its value becomes 1, which is equal to, then 1 by 2 is to be a constant. If you integrate with respect to rho, then it becomes rho square by 2. If you substitute limits as 1 to 2, then and one integration will be z, and substitute limits as 0 to phi, right? So phi equal to 1 by 2 into rho square, means if you substitute rho square by here 2, then it will be 4 by 2 into this z value, if you 4 by 2 minus, and if you substitute 1, then it will be 1 by 2, right? 4 by 2 minus 1 by 2. See, already it is 1 by 2 is there. Then if you substitute upper limit as 2 here, 2 square value is 4, 4 by 2, minus if you substitute lower limit as 1, then 1 by 2 into z value 5 minus 0, which is equal to 1 by 2 into 4 by 2 minus 1 by 2, then it becomes 3 by 2 into 5. So 15 by 4, which is equal to 15 4s are 4 3s are 12. See, 15 by 4, 12. 4 7s are 28, and 2 4 5s means 3.75 Webers is to be obtained. So flux phi is equal to 3.75 Webers is to be obtained. Right? So based upon this, see, given the magnetic vector potential A value is given, that is minus rho square by Az Weber per meter, we need to find the flux which is crossing through that surface. So in order to find the flux psi, then first we need to establish the relation between flux density B and the magnetic vector potential as A, as using the formula B equal to del cross A. Now from that we have got the value of magnetic flux density, and in place of this B in magnetic flux formula, psi is equal to integral S B dot ds, then if you evaluate the complete equation, you're going to get the value as psi is equal to 3.75 Webers. Magnetic flux can be measured in Webers. Hence, psi is equal to 3.75 Webers is to be obtained. Similarly, one more problem is based upon again magnetic flux density and field intensity is a current distribution gives rise to the vector magnetic potential A equal to x square by ax plus y square x ay minus 4xyz az Weber per meter. Calculate first. So from here, the vector potential A, first we need to evaluate B. B at 1, 2, 5 means in the, if you observe in the A magnetic vector potential A, x, y, z coordinates are given. Means a type of coordinate system which we have considered for this problem is rectangular type. So differential components are given by dx, dy and dz. Right? So from that A, the relation between B and A is to be written as P equal to del cross A bar, B bar equal to. So upon expanding this one, first we are in the first row, we are going to write all the unit vectors as Ax, Ay and Az. And in the second case, partial derivative terms dou by dou x, dou by dou y and dou by dou z. And in the third case, we are going to write all the magnitude terms as Ax, Ay, Az. Right? So which is equal to Ax into Ay, then Az, dou by dou x, then dou by dou y and dou by dou z. Now if you substitute in place of all the magnitudes which are given in the Ax, Ay, Az, means Ax value is this, Ay is this, and Az is minus 4 Axyz. So instead, in place of Ax, Ay, Az, by we substitute first value as x square y, next is y square x minus 4 xyz. Right? So we evaluate this equation, which is equal to Now ax into, right? So ax into dou by dou x of, see, ax into means dou by dou y of minus 4xyz means minus 4xz is to be obtained. Then minus dou by dou z of y square x means this will be a 0. Then minus ay into. So minus ay means if you consider first row and the second column, then dou by dou x of this will be minus 4yz minus dou by dou z of x square y will be 0 plus az into. So first row, if you consider first row, third column, determine between these two, dou by dou x of y square x means y square, then minus dou by dou y of x square y becomes x square. Okay, so equal to minus ax into means which is equal to minus, see here, if you simplify this one, which is equal to minus 4xz ax, then already negative is there, minus into minus becomes plus 4yz into ay, then plus y square minus x square into az is to be obtained based upon this b value, which is equal to del cross a. So in this, we will substitute x, y, z by values by here x by minus 1, y by 2 and z by 5. So if we substitute, then it will be equal to. So if we substitute first x and x value by minus 1 and z by 5. So 4 into 5 becomes 20. So minus of minus becomes plus 20 ax. Then minus 4 plus 4 into yz. Y value is 2, z is 5. Then 2 5 is 10. 10 into 4 is 40 ay. Then plus y square. Y square value is 4 and 5 is 5 square is 25. 4 minus 25 is minus 21 az. Right? B value. And in general, this B is measured in Weber per meter square or Tesla. Right? So this is the value for A is to be obtained. 20ax plus 40ay minus 21 is it Weber per meter square. Right? So now the flux through the surface defined by z equal to 1, 0 to 1 is the value of x ranging and y value is to be minus 1 to 4. Again, in this case also, we are supposed to evaluate the flux through the surface, which is defined by, see, x and z are the given values. So as we know that psi is equal to integral s b dot ds. And the formula for ds is given by here. See, the variables which are given is x and y, hence ds is equal to dx into dy into az is to be considered. Now psi is equal to integral x is equal to y equal to. So range of x and y values are given as x is 0 to 1, y is x is 0 to 1, y is minus 1 to 4. And the b value which is to be substituted here. See, without before substituting the constant values of x, y, z, what we have got b as this one. This is b, right? So this value, this is the equation you're supposed to consider, and b value is to be substituted as az component. Why? Because here the z is equal to one plane is given, means xy plane is given. So we need to consider z direction component only. So the z direction component is y square minus x square into az, and the rest will be considered as zeros. Why? Because the dot product representation between two adjacent vectors will be equal to 0. Ax dot ay is equal to 0. Similarly, ay dot az is also 0. So we need to consider, means dot product representation of same two unit vectors value will be equal to 1. That's why ax dot ax is equal to 1 only we are supposed to consider, either ax or ay or az. Hence b will be given by here y square minus x square into az dot. ds formula is dx dy az. Okay, which is equal to integral first. If you are integrating this one with respect to x, means y square means see integration. First, if you are integrating, integral x is equal to 0 to 1, integral y equal to minus 1 to 4, y square into dx dy minus integral x is equal to 0 to 1, integral y equal to minus 1 to 4, x square dx dy. Okay, which is equal to, split this one, y square minus x square into with respect to the separate variables. Hence, y square means y cube by 3 if we substitute limits as minus 1 to 4, and for x it is x and 0 to 1 minus. Similarly, here for x it is x cube by 3 and limits as 0 to 1. Then for y it is 1y and the limits as minus 1 to 4, which is equal to 4 cube as 64 by 3, then minus 1 by 3 into 1 minus 0 as 1, then minus here 1 by 3 into, see, 1 by 3 into, if we substitute 4, minus of minus 1 becomes plus, then 64 by 3 minus 1 by 3 becomes 63 by 3 minus 5 by 3, right? So if you find the LCM as 3 and the 63 minus 5, which is equal to 58 by 3, which is equal to, the approximate value is nothing but 20 webers. Okay, so 58 is approximately equal to 60, then 3 2 gets cancelled, 20 webers is to be obtained. Magnetic flux is generally measured in webers. Okay, so this is the way we have been evaluated. The current distribution gives rise to the vector magnetic potential, which is to be expressed in Cartesian coordinate system, and the variables are defined here x, y, z. Then based upon that, differential components need to be considered as dx, dy, dz. Based upon that, the flux density and the magnetic vector potential relation B equal to del cross A. From that, we have been evaluated magnetic flux density, and this value is to be substituted in magnetic flux, that is psi equal to integral s v dot ds, and in v we need to substitute only z component. Why? Because x component and y component need to be multiplied with unit vector as az, then its value becomes 0. That's why we need to consider only z component. So from this, we'll be getting the value as magnetic flux psi is equal to 20, and it is to be measured with respect to webers. Okay, then next, another problem based upon magnetic flux density and the force equations. Okay, so an electron with velocity u is given as u equal to 3ax plus 12ay minus 4az into 10 power 5 meters per second. So velocity of a electron is given, that is u equal to 3ax plus 12ay minus 4az total into 10 power 5 meters per second. Generally, this unit for this velocity or velocity of an electron can be measured with respect to meters per second, and its value is given by u equal to 3ax plus 12ay minus 4az into 10 power 5, and experiences no net force. No net force means F is equal to 0 here. No net force. The force which is represented with F, and no net force means its value is equal to 0. At a point in a magnetic field B. So magnetic field B is given. It is also a vector, and it is represented with V bar, which is equal to 10ax plus 20ay plus 30 az. Okay, 30 az. Milli Weber per meter square. For this milli, we are representing it with 10 power minus 3. Okay, so this is not there. So 10ax plus 20ay plus 30az milli Weber per meter square is to be obtained. Now find E at this point. So we have got here U value as 3ax plus 12ay minus 4az into 10 power 5 meters per second, and B value is to be obtained as 10 AX plus 20 AY plus 30 AZ milliweber per meter square or Tesla. Then based upon this U and B, we are going to evaluate the E value. So according to the Lorentz force equation, that is if the electric field, the total force which is due to electric as well as magnetic fields, and that is given by F equal to Fe plus Fm, right? So F equal to Fe plus Fm. So now to find that Fe and Fm, first E is given by Q into E, that is to be obtained and from the electric fields, and Fm is given as Fm equal to, that is E into U cross B into that charge Q into E plus U cross B, right? So if you multiply, if you add, if you are going to add these two, then it will be total force due to electric as well as magnetic fields is to be obtained as F equal to Fe plus Fm. Then Fe means Q into E plus Q into E plus U cross B, right? So in between these two, if you evaluate total equation, if you multiply these two, then you're going to add, that will be, see here, so which is equal to Q into E plus U cross B. If you apply the Stokes theorem to the LHS parts as well as RHS part, and if you convert that into integral part to the differential equations, then the total force which is due to electric as well as magnetic fields is to be obtained as Q into E plus U cross B. Now from the given, see, an electron with a velocity u is given, that is 3ax plus 12ay minus 4az into 10 power 5 meters per second, and experiences no net force at a point in a magnetic field B is to be given. So now q into E plus U cross B equal to F. No net force means we are substituting F by 0, right? So F by 0 means 0 equal to Q into E plus U cross V. Okay, so Q equal to 0, then this becomes E plus U bar cross V bar equal to 0. Now from this we are going to evaluate E. Why? Because find E at that particular point means E bar equal to minus of U bar cross V bar, right? So minus of U bar cross B bar means we will evaluate this equation as E equal to minus of AX, AY, AZ. First we are considering U vector. U vector has magnitude 3, 12 and minus 4. And for B vector is 10, 20 and 30, right? Which is equal to. So now to evaluate this one, first, so E equal to minus AX into, so 12 into 30, that is 360 minus already negative is there, then minus of minus becomes plus 80, 3 is a 36, 36 plus 80, then minus AY into, so 90, then plus 40. Why? Because 3 into 30, 90, and already in the formula itself negative is there, then minus of this minus becomes plus, then 90 plus 40. Then plus AZ into, AZ into means 3 into 20 is 60, then minus 12 into 10 becomes 120 equal to minus AX into 360 plus 80, that is 40, 440, right? So minus 130 AY, then minus is 60 AZ E, and this E is to be measured with respect to volts per meter, or according to the newtons it is Newton per coulomb. Why? Because E equal to, in general we can define it as F by Q, and according to this Newton's force F is measured in newtons, and electric charge can be measured in coulombs. That's why the E can be obtained as minus 44 AX, then minus 130, 440 AX, minus 130 AY, minus 60 AZ volts per meter. Or in general, it is measured in Newton per coulombs also sometimes. Right? So if you evaluate the total thing here, then F equal to Fe plus Fm, we substitute net force by 0, then we'll be getting its value as E bar equal to, now it will be minus 440 AX plus 130 AY minus 60 AZ volts per meter or Newton per coulomb. Right? So electric field intensity E is to be obtained. Right? So this is the way we have evaluated, we have solved some of the problems based upon magnetic field intensity and magnetic flux density. So in order to solve all such, first we need to remember how the magnetic field intensity H is to be measured. That is, H is to be measured in ampere per meter, and second one is magnetic flux density B is to be measured in Weber per meter square or sometimes Tesla, and the relation between two are given by B equal to mu into H, and this mu is given by permeability of the magnetic field intensity, that is mu equal to mu naught into mu r. For a free space medium, its value is given by mu r equal to 1, hence mu is equal to mu naught, and its value is equal to 4 pi into 10 power minus 7, and this Henry per meter. It is to be measured in Henry per meter. And we use one of the formula, the relation between magnetic flux density and magnetic field intensity, magnetic vector potential, as V equal to del cross A bar. Upon evaluation of this one, del cross A bar, we are going to consider it as a Cartesian coordinate system or rectangular coordinate system. We use the formulas, all the unit vectors are first we need to write, and the partial derivative terms as dou by dou x, dou by dou y, and dou by dou z, and all the magnitudes related to the xyz directions respectively can be written just like this. This is the one of the formula already we have used. And the relation between magnetic flux density B bar and the magnetic flux psi is given by here. Psi is equal to integral S B dot ds. Depending upon the B direction, we are going to write the formula for the ds. Suppose if you want to write the differential components for Cartesian coordinate system, then it is dx, dy, and dz. If you substitute here v by ds formula by ad with respect to the xy plane, then ds becomes dx and the dy. Vector direction is az. Or if you want to write the plane equation for yz, then it will be dy dz into ax. Or if you want to write the xz directions, means dx dz into ay. Like this, you are supposed to consider the formulas for differential surface area in the Cartesian coordinate system, and substitute all this ds values in this, and with respect to the flux density B formula, then psi is equal to integral S B dot ds. And generally this magnetic flux can be measured in Webers. Okay, what we have in the last sum we have evaluated the equation for electric field intensity E, and this is to be measured in volts per meter, or sometimes it might be Newton per coulomb also. Okay, so this is the way we have solved some of the problems based upon magnetic flux density and magnetic field intensity. Okay? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.